Hi, this is Lee McDonough, and this is my Environmental Geology 106 video project. To start off, I will be telling you guys about plate tectonic boundary motion and their relation to volcanic activity. To first get an understanding of plate tectonic motion, we need to understand that plate boundaries are characterized into three groups: divergent, convergent, and transform boundaries. On page 54 of the ebook, it states how divergent boundaries move away from each other, creating a little gap between the two plates. An example of a divergent boundary would be the mid-ocean ridges that you will find in the Atlantic Ocean. On page 56 of the same ebook, it explains convergent boundaries as plate boundaries that move towards one another, although convergent boundaries can also be explained into three subgroups such as ocean-continent, continent-continent, and ocean-ocean. A great example of a convergent boundary would be along the Andes Mountains in Chile, which is an ocean continent. On page 58, a transform boundary is explained as two plates moving parallel with one another but in opposite directions. A great example of this would be the San Andreas Fault on the west coast. We can also correlate these boundaries with the creation or destruction of crust. Divergent boundaries are correlated with the creation of crust. This is because since the plates are moving away from one another, it allows for newer hot crust from the upper mantle to come to the top and spill over. Convergent boundaries are correlated with the destruction of crust. This is because as the plates move towards one another, the denser oceanic crust will subduct underneath the thicker continental crust. Ocean-ocean convergence follows the same process. The denser ocean crust will subduct below the younger ocean crust. And continent-continent convergence will not subduct because when they meet, they both push up on one another, creating large mountain ranges with no subduction underneath, such as the Himalayas. Transform boundaries are not correlated with the creation nor destruction of crust because no crust is being subducted down below or being brought up through the cracks or holes that you see in convergent and divergent boundaries. We can correlate these boundaries with volcanism based on the creation or destruction of crust. With divergent boundaries, because new crust and magma rises through the gaps that it creates, volcanism is present, although it is almost always smaller eruptions such as fissure eruptions. Most convergent boundaries are correlated with larger volcanic activity. Continent-continent convergence, though, is not correlated because there is no subduction. But in the other types of convergent boundaries, because one plate subducts beneath the other, it allows for water and rocks to melt and rise, creating magma and create enough pressure to allow volcanic activity. And finally, with transform boundaries, like I said earlier, there is no creation or destruction of crust, disallowing volcanic activity to be present. Thank you so much for watching my video on how different plate boundary motion is associated with volcanic activity.